Hi, this is Alex from devstories.eu. PySpark Fundamentals, Episode 5 of 21. Relying on automatic schema inference might save you a few lines of code, but it will cost you dearly in production performance. The cluster often has to read your entire dataset just to guess what is inside before doing any actual work. You fix this by mastering basic data types and explicit schemas. It is common to confuse standard Python types with PySpark data types. When you declare an integer or a string in standard Python, that object lives in your local machine's memory. PySpark types operate on a completely different level. They are mapping instructions for the Catalyst optimizer and the underlying Java virtual machine. When you use PySpark data types, you are defining a strict, cluster-aware structure. This guarantees data consistency across hundreds of distributed worker nodes and dictates exactly how data is serialized over the network. PySpark provides a specific type for every standard data shape, and selecting the correct one is crucial for performance. For numbers, you have byte type for very small integers, integer type for standard numbers, and long type for large values. Selecting byte type instead of long type for a simple status code saves significant memory when that choice is multiplied across billions of rows. For text and logic, you use string type and Boolean type. Handling time correctly is another area where exact typing matters. PySpark splits temporal data into date type and timestamp type. You use date type when you only care about the calendar date, like a user's birthday. You use timestamp type when you need exact points in time, tracking both the date and the exact hour, minute, and second an event occurred. Knowing these types is only the foundation. You must apply them directly to your data ingestion process using an explicit schema. You construct the schema using two specific objects, StructType and StructField. You can think of a StructType as the blueprint for an entire row in your data frame. A StructField is the blueprint for a single column within that row. To build an explicit schema, you instantiate a struct type and provide it with a collection of struct fields. Every struct field requires three specific arguments. First, you provide the column name as a standard string. Second, you pass the specific PySpark data type you want to enforce, like integer type or string type. Third, you provide a Boolean flag indicating whether this column is allowed to contain null values. For example, you construct a schema starting with a struct field called user_identifier assigned to a string type and set the null flag to false. You follow this with a struct field called accountAge assigned to an integer type, setting the null flag to true. Once this struct type object is fully assembled, you pass it directly to your data frame reader using the schema method before you call the load command to read your files. This is the part that matters. When you provide this explicit schema up front, PySpark completely skips the data scanning phase. It applies your blueprint directly to the incoming data stream. This drastically reduces the time it takes to read a file. It also acts as an immediate quality gate. If a malformed file arrives with text in your integer column, the pipeline handles it based on your defined structure, rather than silently shifting the inferred schema downstream and breaking your transformations. Defining your schema explicitly transforms a fragile, expensive read operation into a predictable, highly optimized pipeline step. Thanks for listening. Happy coding, everyone.